free topic today will be conditional statements.
Logic is based off conditional statements. A conditional statement is a statement that A can be written in if-then format, and B consists of both a hypothesis and conclusion. An example of this would be, if it is raining, then it is wet outside.
Conditional statements are, once again, statements written in an if-then format. Some examples would be, a mammal is a warm-blooded animal. Your hypothesis would be, an animal is a mammal, and your conclusion would be, it is warm-blooded. So, if an animal is a mammal, then it is warm-blooded. A more math-related example would be, a prism with bases that are regular polygons is a regular prism. Your hypothesis would be, a prism that has bases are regular polygons, and your conclusion would be, it is therefore a regular prism. If a prism has bases that are regular polygons, then it is a regular prism. Conditionals are other statements that are based off the conditional statement. There are three types: the converse, inverse, and contrapositive. A logically equivalent statement are statements that have the same amount of truth, or truth value. The conditional and contrapositive are logically equivalent to each other, and the converse and inverse are logically equivalent to each other.
Conditional statement is the converse. An example of the converse is, if it is wet outside, then it is raining. But as you can see, this is false, because it can be wet outside for a number of reasons. The conditional statement is the inverse. The inverse is negation of P and Q. An example of this would be, if it is not raining, then it is not wet outside. But that's false. As you can see, it is wet outside, but it's not raining right now. An example of a conditional statement is the contrapositive. The contrapositive is the reverse and negation of both P and Q. For example, if it is not wet outside, then it is not raining. This is true.
Our most important topics for this are inductive and deductive reasoning. Inductive reasoning is reasoning that uses a number of specific examples to arrive at a general conclusion. This reasoning is not always a valid method of proving a conjecture because it uses assumptions. A conjecture, for the record, is a concluding statement reached using inductive reasoning. An example of inductive reasoning is if you see 5 blue birds in the city of La Cañada, then you automatically assume that all birds in La Cañada are blue. Naturally, this is an incorrect statement, which is why inductive reasoning is considered flawed. But it is still an example of the use of inductive reasoning, and it can, in fact, be correct, just not always. Truth value of a statement is measured by how the statement is either valid and/or sound. If this argument is valid, that means it is logically correct and follows a logical law. And if it is sound, that means its premise is true. An argument does not have to be valid to be sound, and vice versa. An example of a valid statement is, if it is raining outside, then it is wet outside. This is an example of a perfectly valid statement, and it is sound. A statement does not have to be in a sound premise. For instance, if a student is a tangerine, then the sky is full of cars. This is obviously incorrect to most of us, but it is still considered a valid statement, although it's unsound. Deductive reasoning is reasoning that uses facts, rules, definitions, or properties to reach a logical conclusion from given statements. It is where, as opposed to inductive reasoning, you go from a specific number of cases to a general case. For instance, if you imply that all mammals have warm blood and you see a human, and you know that humans are mammals, then you know that it is a human that has warm blood. When you are going through reasoning, it is important to know the logical laws that a statement must follow. The laws are the law of detachment, the law of syllogism, and modus tollens. Each of these has their own properties and can each be used to solve a problem of logic. The law of detachment is a law of reasoning in which if P to Q, your hypothesis to conclusion is a true statement, and your hypothesis is true, then your conclusion must be true. An example of this would be if you are given if a car is out of gas, then it will not start, and you know your car is out of gas. Then your conclusion through the law of detachment will be, since your car is out of gas, then it will not start. The law of syllogism is essentially the transitive property but applied to logic. For instance, if your statement P to Q is true and Q to R is true, then P to R is true. For an example, if you get a job, then you will earn money. If you earn money, then you can buy a car. So, through the law of syllogism, if you get a job, then you can buy a car. The last law is modus tollens. Modus tollens, if Q never happened, then P never happened. If the negation of the conclusion is true, then the negation of the hypothesis is true. An example of this would be, if someone trips you, then you will fall. By modus tollens, if you did not fall, then nobody could have tripped you. Modus tollens should not be confused with an invalid statement. If P never happened, then Q never happened. Another factor can cause Q to happen, such as R. An example would be, if she eats the food, then she will get sick, and she didn't eat the food. The conclusion can't exactly be she will not be sick. There's more than one way she can get sick. The correct way to use modus tollens is, if she eats the food, then she will get sick. She didn't get sick. By modus tollens, she didn't eat the food. Some common examples of deductive reasoning problems come as the following. So, use the initial directions to find the answer. For instance, if a triangle is a right triangle, then it has an angle that measures 90 degrees. If a triangle has an angle that measures 90 degrees, then its acute angles are complementary. So which of the next statements can you determine an answer from? A, if the triangle is not a right triangle, then it has an angle that measures 90 degrees. B, if an angle of a triangle measures 90 degrees, then its acute angles are not complementary. C, if a triangle is a right triangle, then its acute angles are complementary. And D, if a triangle has an angle that measures 90 degrees, then it is not a right triangle. The correct answer is C, and you can use the law of syllogism to draw this conclusion. Another common example of problems would be deciding whether something is inductive or deductive reasoning. So determine which of these statements are deductive. A dental assistant notices a patient has never been on time for an appointment. She concludes that her patient will be late for her next appointment. That is statement 1. Statement 2. If Eduardo decides to go to the concert tonight, he will miss football practice. Tonight, Eduardo went to a concert. Eduardo missed football practice. Which of those is deductive reasoning? It's true that statement 2 with Eduardo is the deductive reasoning problem because he went from a general example to a specific example. Finally, proofs. A proof is our hardest topic. A proof is defined as a logical argument in which each statement is supported by a statement that is accepted as true. It seems daunting when you rephrase it like that, but we'll explain it to you step by step. Proofs explain why something is true. Deductive reasoning must be used to move from the hypothesis, which is given, to the conclusion, which is proof. The different types of proof usually include informal, paragraph, and two-column. Postulates, definitions, properties, and theorems are all used to support your argument. Your postulate is a statement that is accepted as true without proof, and a theorem is a statement that can be proven true. Paragraph proofs are fairly simple. They're where you're given, and it's where you simply write a paragraph and each sentence continues to explain further why your statement is true. Instead, I'd like to talk about the more complicated version, and that would be two-column proofs. Two-column proofs follow this format right here, in which you have your statements here and your reasons here. This will be your postulates, theorems, etc., etc. So when you write your two-column proof, you have your statement and your reason. And you have to have them right order, right end of the way. Your statement 1 is almost always going to be your given. You're given a statement that when you're given a two-column proof problem, you just automatically get that one as a freebie to help get you started on your way while you're solving the proof. The rest are where you solve on your own. Sometimes there's some where you just have to fill it in, and some of them are solved. Usually you have to fill in the rest. In statement 2, you have your reason 2. And you continue to just go down until you reach your final statement, and once you have your final statement and reason, you have officially solved the problem. So for our problem, we have the directions are write a two-column proof. So your given is that given that SC is congruent to HR, and HR is congruent to AB, and you have to prove that SC is congruent to AB. Well, if you see that SC is congruent to HR and HR is congruent to AB, then if you look at this, you can easily see that since you know this is true, then you have to know that this is true due to the transitive property. So while this is a simple proof, this idea is applied to almost all proofs, and as such, you go through this step-by-step process in order to solve these problems. So we have to finish with one more example of a proof that isn't two steps. So for our final proof, we have you're given that DB bisects angle ACD. We have to prove that angle 2 is congruent to angle 3. So if you look at the diagram here, you can get a general idea of what this problem is about because it illustrates the entire problem. So then let's turn to our proof. First statement is that DB bisects ACD, which is what we were given from the very beginning. Our first statement that is made is that angle 1 is congruent to angle 2, and that's because of the definition of an angle bisector. So our next statement would be that angle 3 and angle 1 are vertical angles, and that is the definition of a vertical angle. 4 is that angle 3 is congruent to angle 1, because vertical angles are always congruent. Our fifth step would be that angle 3 is congruent to angle 2, which is an example of the transitive property, and we can conclude with angle 2 is congruent to angle 3 due to symmetric property.